We have come to what I think is one of the most important concepts in JavaScript, closure. You need to understand and use closure to be a serious JavaScript developer. Now, closure is something that is not understood by new JavaScript developers. I can remember when I first got the idea or understood the idea of closure. It was an aha moment for me. And then I was able to see it in lots of code and use it to solve particular problems. So first, I want to look at a definition. This comes from Kyle Simpson. He states, closure is when a function is able to remember and access its lexical scope even when that function is executing outside its lexical scope. So variables and functions from its lexical scope are still accessible to a function, even if that lexical scope is not the currently executing environment. Now, those variables and functions are held in memory because the JavaScript engine sees that there is still something that could reference them. Now, when does this type of thing happen? When does a function execute outside its lexical scope? Well, it's really quite frequent, but to know that and to explain it better, we need to start looking at some examples. So the first example I want to look at, I'm going to call this function delayed greeting. And we're going to look at how this works, and then I'm going to explain what is going on and what closure is happening. So we have a function here that we're able to pass in a parameter name. This is going to do a greeting for us. We're going to declare two variables inside of this function. One is the greeting, good morning. We'll do a space after that. And then I'm going to use one let to declare both of these. The other one is a punct variable for punctuation. And we're just going to set that to an exclamation point. That's all. So there's our two variables. Now, all we're going to add is a set timeout. We've used this a lot in the past, so this will be a great way to illustrate closure. Set timeout is having a function passed into it, as we know. That function will not invoke until after the time is expired. And when the time is expired, if you remember, the function is placed on the queue. And then once no other JavaScript is executing, it's then added to the stack and is executed. Now here's what we're going to log. We're just going to log the greet variable plus the name that's passed in and plus punct. All right, now let's go ahead and set this to 5 seconds. Like that. All right, now let me talk about this in terms of closure before we actually watch it. And let me go ahead and do delayed greeting down here so it'll invoke it. But in terms of closure, so we load this JavaScript file and the function, and as we begin executing the code, we encounter this, we add a function to it, and then we encounter this, which invokes it. That function is then placed on the stack and it begins to work through the code inside it. Creates an execution context for this code. And so this variable and this variable and this variable is all accessible by the code inside the function. Well, it encounters a set timeout, and set timeout is handled by the browser, as we know. And so the browser starts counting down the 5 seconds. Well, that function completes. It's done before this countdown is finished. It is done and is removed from the stack. So what happens to these variables? Are they still accessible by this function? Because that function is not even added to the queue yet. We're still counting down the 5 seconds. Then it gets added to the queue, and then when there is room, it gets added to the stack, and then it begins executing the code inside it. So here's the code inside it, and now it's got to grab greet, name, and punct. But this function's already removed from the stack. So what happens? Well, this is where closure comes in. because the JavaScript engine knows that this function still has a reference to these variables, which are part of its lexical scope, lexical where it is written, and this is the scope here. So it still has access to that. These are retained in memory, even though this function has finished executing and is removed from the stack. These variables are not cleaned up. They're retained in memory, so this function then is able to access them because they were a part of its lexical scope. So the JavaScript engine knows enough to keep them around to be able to use them. So that is closure. Closure is created around those variables so that this function later on can still access them. A very powerful feature if you think about it. We can have something execute and finish and still have access to the variables. Very powerful. Okay, so I want to save this. Then I'm going to reduce this a bit. Let's go ahead and open up the console. There's my initial return. I want to put a name in there. Why did I not put a name when I called that? Okay, Steve, like that. All right, now we'll save it. Okay, the function's gone. It's counting down, counting down, counting down. 5 seconds is up. We get good morning, Steve. It still has access to all of those variables because of closure. So as I stated, the function is removed from the stack. But despite that, the variables are still retained in memory because the engine knows something else could be referencing them. So it could be variables. It could be a function that this function calls. Those are all retained in memory so that they are accessed. As long as it's part of the lexical scope, then it'll have access to them. And they will not be cleaned up by the JavaScript engine. All right, let's do another example. I'm going to go to the HTML file here, and I'm going to add 2 buttons. And I want the first button to have a button ID of 1. So I'm using the Emmet shortcut to do that. Emmet is a plugin for Visual Studio Code. When I press Tab, it creates the button for me with the correct button ID. And I'm going to name the button Click Me, like this. Okay, now we're going to put another button here. And I want this one to also have an ID, but this one will be BTN2. And I'm going to do Click Me 2, like that. So those are 2 buttons that we've added. If I save that, let's see if those are showing up. Yes, they're right here. And now we get that message. That code is still working. So if I come over here, I'm going to comment that out for just a minute while we do something else. So what I want to do is create an initialize function. This is a function we're going to run when this page loads, and it's going to initialize some things, mainly the event listener. So I'm going to call it initialize. And then I'm going to put some variables here. Now maybe you can get an idea of what I'm doing here with closure. I'm going to set up 2 variables, and both of these variables are still going to be accessible even after this initialize function is completely done. So the initialize function is going to run first. It's going to set up the event listeners that I'm doing right now. Let's see, BTN1 is one of those that I want to do. Add event listener, and we're going to use the click event. It's going to set those up, and then it's going to be finished. But even with it being finished, we're going to still have access to those variables. We'll see how we can deal with that. So one of the things we're going to do is CNT. We're just going to increment that first variable there, and then log to the console CNT. That's what we'll do in this first one, like that. And let me go ahead and semicolon there and semicolon there. And I'm just going to copy this one and basically do a similar type of thing for the next one down here. But this time we're going to do BTN2. And this time we're going to increment the count, but we're going to do it with the increment amount. So we'll do a plus equal increment like that. And then we'll log the count to the console again. All right, we've got that set up. Now, when the page loads, I'm going to call initialize. So that's going to run, and it's going to be removed from the stack. However, these variables will be retained in memory because they're referenced by these functions here, these anonymous functions that are part of the event listener. So who knows how long it will go after this function has completed before these buttons are even clicked. It really doesn't matter how long. It could be years as long as that page stays active. It will retain these in memory and it will have access to them. All right, so let's save that. And now obviously that initialize function has already been completed. Let's go ahead and do click me and we get logged to the console. Let's click this one over here. Is it going to remember this number that was incremented here? It does. It adds 2 more to it. And I click this one, it adds 1 to it. So 2 different functions, but they're addressing the same lexical scope. So they're addressing the same variable. And because of closure, those variables are retained. They're accessed by both those functions. You can get an idea now of the power that closure can provide in JavaScript. It is really an important feature of JavaScript. So we provided the first examples of closure using setTimeout and also using addEventListener. Well, what I want to do next in the next topic is we're going to use a higher order function to show the application of closure as well. So let's move on to the next topic.